Hi everyone, so welcome to the new outline of this course, which is statistics. This video is part 1. Let's see the learning objectives of today's lecture. The learning objectives of this lecture are to: what is statistics, how statistics is used, how we can use min and max functions in our studio, what is mean, median, and mode. So what is statistics? A type of mathematical study used to examine and draw conclusions about the data is called statistics. You can use the applied facts to your advantage by using statistical analysis. Statistics provides us with more precise and efficient ways to learn from data. Making future forecasts is one area where statistics can be used. It may also concentrate on illuminating the relationships between various elements. Several fundamental statistics are as follows: minimum and maximum value, mean, median, and mode, percentiles, variance and standard deviation, covariance and correlation. R is a programming language that has many built-in functionalities, in addition to libraries for the exact purpose of statistical analysis. This language was developed by two statisticians and is used for environmental statistical computing and graphics. It's an introduction to all basic statistical concepts like plotting, graphs, etc. So, how statistics is used? Statistics can be used to explain things in an accurate way. It can be used to comprehend and draw conclusions about the group you are interested in learning more about. This group is called the population. A population could consist of numerous types of groups. It could be all of the people in a country, all the business in an industry, all the customers of a business, or it can be all the people that play football who are older than 45 and so on. You can get a sample by gathering information about the population of the entire population. This is a portion. On that simple, statistical techniques are then applied. To conclude about the population, conclusions are based on the results of a statistical procedures applied to that sample. R has several built-in mathematical functions, such as min function, which is used to find the lowest value in a set. Then we have max function, which is used to find the highest value in a set. We have a further extension of these functions below, such as which.min function, which is used to find the index position of the minimum value in the table. Then we have which.max function, which is used to find the index position of the maximum value in the table. Note, we can also combine which.max function and which.min function with the row names function. Let's move to our studio to see how it works. All right, first of all, I will load the library, dplyr, and here I will say I want to read my dataset and sleep, and I will use the function read.csv. The name of dataset is msleep.csv, and here I will say print head and then msleep. All right, but before that, I have to set my working directory. I'll say go to D and data size R. So you can see the head of your dataset right here. Now let's say I want to know the minimum body weight of a mammal. So first of all, I will use the function min. All right, and here I will pass the data frame mSleep, and I will say take the variable of body weight and run it. So you can see here that the minimum weight of the body is 0.005. Now it's time to see the maximum body weight. I will use the max function. Here I will pass the data frame, and inside this data frame, I will say take the variable of body weight. Let's run it. I used the ampersand sign. I should have used the dollar sign. All right, so you can see here that the maximum body weight is 6,654. For instance, I want to know the position of these body weights. So I will use the function of which dot minimum at first, and I will say take the mSleep data frame and the variable of body weight. The index position for this body weight is 17. Just like that, I will say print which dot max. I will say take this mSleep data frame and find me the body weight. The index position for this maximum body weight is 36. So just like I have mentioned earlier, you can also use the row names function in combination with these which dot min and which dot maximum function to find out the index, such as I say row names, and I say take this mSleep data frame and which dot minimum, take this data frame and take this variable of body weight. See, the output is same for both of them. Now let's move back to slides. Measure of central tendency. The measure of central tendency in our language represents the whole set of data by a single value, as it gives us the location of central points. The three primary measurements of central tendency are as follows. First one is mean, the second one is median, and the third one is mode. Averages are indicators of where the center is located. An average serves as a gauge for where the majority of the data values are distributed. So what is actually mean? It is calculated by dividing the total number of observations by the sum of observations. The sum divided by the count is also used to define the average. The mean is calculated for numerical variables. A variable is something in the data that can vary, like age, height, income, etc. It's known as the average value. To calculate the average value or mean of a variable from the dataset, the function of mean is used to calculate this in R. The syntax is quite simple and as follows. You just use the mean keyword, then pass the variable or data frame, then some parameters. Let's move to RStudio. Let's say I have a variable named S1, and inside this variable, I have vector values such as 2, 4, 6, 8, and 10. Now, as I want to see the mean of var1, I will use the mean function, and here I will pass var1. So you can see here that the mean or the average value of this vector is 6. Now, for instance, I use a parameter in the mean function, and I say take this var1, but this time I will use the parameter of trim, and I say that trim the value equals to 0.1. So it will trim one value from each side of the vector, which is gonna be 2 and 10. Let's run it. You can see here that 4 plus 6 plus 8 is 18, and 18 divided by 3 is 16. Now, for instance, you have another variable as var2, and in this variable, you have values like 2, 4, 6, 8, and 10, and also a value as na. Now, this time, I will say print mean of var2. So you can see here that it has given us the no value because there was a no value in the vector. In order to escape the null values from your variable or the column of a data frame, you can use the parameter of na.rm equals to true. So this time it will run perfectly. Now, similarly, you know that you have a data set mSleep, and let's say I want to see the mean of body weight. First of all, I will pass the data frame and then the variable, which is body weight. The mean body weight of the mammals is 166.1. Now let's move back to slides. So next we have median. Median is the midway value in a data series that is referred to as median. Luckily, R has a function that does that all for you. R uses the median function to determine this value. It splits the data into two halves. The median is the average of the two central components if the number of items in the data set is even. If the number of elements is odd, the median is the center element. The syntax is as follows. Just use the median keyword, pass the data frame or variable, then some parameters. Let's move to RStudio. So let's say we have a variable var1. All right. Now, in this variable, you can see here that the middle value is 6. So the median of var1 should be 6. Now, let's say I want to calculate the median of body weight. I say print, and I say median. Here, I pass the data frame, and then the variable, which is body weight. And I also pass a parameter na.rm equals to true, because I'm afraid that this column also contains some missing values or no values. Let's run it. So the median is 1.67. Now let's move back to slides. Next we have mode. The mode value is the one that appears the most frequently. If all of the data points have the same frequency, the dataset might not have a mode. Additionally, if we have 2 or more data points with the same frequency, we have more than one mode. The mode, which indicates where the majority of the data is placed, is a form of average value. Multiple values that are modes may exist in a dataset, such as unimodality. It refers to distribution of values with only one mode. Then we have bimodal, which refers to a value distribution with 2 modes. Next, we have multimodal, which is in fact a distribution with multiple modes. Others don't have a mode calculation function. To find it, we can, however, design our own function. We can use the following code. So let's use this function. Let's say I have a variable var3, and in this vector, I have some values such as 2, 4, 6, 8, 10, 4, 4, 4, and 4. Now, in order to calculate the mode, I will say my mode, and here I will use the function keyword. I will pass the variable, which is var3, and here I say my mode, and I give var3 as a parameter, and here I say return names sort minus table, and here I pass the variable, and I say take index 1. All right, let's run it. So you can see here that the frequency of 4 was the highest. That's why the mode is 4. For instance, I have a variable as var4, and inside this vector, I have apple, banana, and I have another apple. And I say calculate the mode for var4. It should be apple. In contrast to the mean and median, the mode can include both numerical and character data, which we have just seen. We can also use the following to calculate the mode. Let's use this function. I will say my mode 2, and I create one more function for calculating the mode. My mode 2, and I will say calculate the mode for var4, and here I give this variable as var4, and first of all I say unique values, and inside this variable I will find out the unique values for var4. Next I will say table equals to table, and tabulate match var4 and unique values, and then I say unique values and table equals to max table. All right, let's run it. So you can see here that the output is same for both of the mode functions. Now let's move back to slides. So this is the end of today's video. I have got some homework for you. You have to apply the min and max functions. Then you have to find the mean, median, and mode. This is the link of the dataset, which you can access by one click. Now good luck. See you next time.